So in this tutorial, we're just going to go over the IUPAC nomenclature. So specifically, we'll be talking about how to name alkanes, which of course will give us a foundation for naming all the other compounds in terms of the basic rules. Okay, so a few things that I expect you to know before we start the process is the prefixes. So for the prefixes, now of course, let me tell you that the alkanes, for actually all the compounds we have, we apply these 10 prefixes. Okay, of which the first one is methane. Okay, the second one is ethane. The third one, propane. Fourth one, butane. Number 5 is pentane. So if you know the polygons, you should be able to name from number 5. And then number 6 is called hexane. Number 7, heptane. Number 8, octane. Number 9, nonane. That should be an N there. Nonane. And then finally number 10 is decane. Okay, so the prefixes themselves that we're getting here are these. Meth. So remove ane at the end there. What you get is a prefix that we're interested in. That will be used to name even the other hydrocarbons and the other compounds we're going to talk about. And then the other thing that I would want to actually mention is that in terms of naming, the structure we're going to be using will be based on the aspect of adding a prefix, and then from the prefix you go to the parent, and then from the parent you get to the suffix. The suffix of course comes at the end, the prefix comes before the actual term. For example, if I say 2-ethyl, and then we end up with, let's say, cyclo what? Let me not even add cycle, let me just say decane. So what you're seeing in this case is this is called the prefix. We're also going to be calling it the substituent. Okay, and then this is the family name or the parent name or the root. Okay, so of course we understand that this one is going to be the longest continuous carbon chain, and then at the end, of course, the last 3 letters in this case are denoting the family of compound, which is like determined by the functional group. So in a case where you may have something, okay, where you may have a different functional group apart from the one that we have from the normal alkane. For example, if we have a carboxylic group attached to decane, the name would change. Okay, it would become a carboxylic acid, right? So it would become decanoic acid. So the prefix changes dependent on the functional group that is part of that structure that you have, or that compound that you have. Okay, then the other few basics that I would also want you to know of is the aspect of propyl. Okay, or actually before even the propyl, I need to mention how we convert from alkanes to alkyls. Okay, so we already know that the general formula of alkanes is as follows: Cn, and then it becomes, for the hydrocarbons, for the hydrogens, they're dependent on twice that plus a 2, which tells us that if you have C2, for the hydrogen it's going to be twice 2, giving us 4 plus 2, giving us 6. So this is called, of course, for the second one, it's ethane, right? Now, if we get to draw ethane by a simple Lewis structure, this is something that is going to come out this way. So we have 2 carbons, and then we've got 6 hydrogens attached to them. Okay, so hydrogen, 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 and hydrogen. That is ethane. Now in a case where I can draw it this way and then add hydrogens there, and then I leave one open, so the name changes. It now becomes an ethyl and no longer an alkane because of a less hydrogen we have. So it is C2H5. So each time you want to convert an alkane into an alkyl, you just remove a single hydrogen atom. So which tells us that the general formula, of course, will just be +1 for the alkyl. Okay. Now this is very important because as you begin to look at substituents which are going to be like attached to the parent structure or the root, they will usually be less by a 1 due to the part that they use to connect the main chain. Okay. Now one special alkyl that you need to know of is what we call isopropyl. So of course iso, I believe you know it means centered or something like that. So whenever we've got 3 carbons connecting to each other, okay, whenever we've got 3 carbons connecting to each other in a way that better summarized, I would put it this way. Okay, so if you've got this kind of a connection, that kind of an intersection, okay, it forms what we are now calling the isopropyl. The isopropyl. So what is an isopropyl? What is an isopropyl? So an isopropyl is an alkyl, first of all, because it ends with YL, right? That's the main reason why it is an isopropyl. It is an alkyl. So propyl, prop means three carbons, right? So if you have CH3, CH, CH3, the centered carbon is the one that is connecting to a substituent. This is called an isopropyl. An isopropyl. So both sides are equal, and then the middle requires or lacks a hydrogen. So we can describe this also this way again. So this is complete. Of course, we've already talked about the skeletal structures. If you've not watched that video, make sure you do watch the video about skeletal structure. So in other terms, at the end there, it means we've got the methyl groups. Okay, so that one there tells us is the carbon or the bond that is missing a hydrogen. Remember, it is not a full line because we don't have a carbon at the end. So in short, if we are to draw the skeletal structure, it is just like that. Something that is like this. That's a skeletal structure. Now one thing that we understand is at the middle there is of course lacking a hydrogen. Okay, so this is what we call now the isopropyl. Okay, it's going to be very useful, very important. Each time you have got a main chain like this, and then you have a propyl joining using their middle carbon, the substituent is going to be called isopropyl, as you'll see later on as we proceed. Okay, I think now we are ready to look at the rules. I don't know, I've taken 9 minutes just to give an introduction. I wished I finished like in 2 minutes or so. Alright, so we'll basically get to establish the rules by looking at examples. I wouldn't want to just list them because it would confuse you. So if you look at this, I believe some of you, before even watching the video, you've already studied a bit of some of your notes. Or if it's your first time, don't worry, we'll still get from scratch. So look at this. How best can we name this? How best can we name this? Okay, so one thing that I would want you to know is the longest chain can be in any direction. Okay, so I'm trying to give you an example. So you've seen, if we add this existing, the longest chain would be obviously something like this. So we'd count that as our longest or our main chain. In such a case, this guy would be taken as a substituent, meaning that it would be a prefix. Okay? In such a case, a name would be, if you look at the substituent, how many carbons does it have? So a substituent is also called a subchain. Okay? Or a prefix. Yeah. So the subchain in this case would be, that is of course propyl. Now it is connecting using the last carbon, so it's not iso, so it's just propyl. So we'd call that propyl. And then you count the longest chain this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10. Okay. So since there are 10, it's decane at the end there. Now we need to also take note of the position where the substituent is connecting. Of course, count from the side where it is shorter. So if we start from down here, 1, 2, 3, 4, 5, 6, it would be number 6. If you start from this end, 1, 2, 3, 4, 5. So it's at position 5 from the other end. So that would mean 5 propyl. I don't know if I counted correctly. These are supposed to be like 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not 10. So 5 propyl decane. Okay? That's how easily we can name that. So that's just like an example. Now let's name the actual structure that we have. How would you name it? So obviously this one is very simple. The longest chain that you can clearly see is the horizontal one. So just count them. So 1, 2, 3, 4, 5, 6, 7, and 8. So what does that tell us? That tells us that the parent name is octane as an alkane. Okay? The prefixes, how many substituents or subchains do we have? We just have a single one, which is clearly only having a single carbon. So from our prefixes, we said meth, then we have ethane, we had propane, butane, pentane. So in terms of an alkyl, since it is less by a single hydrogen, which is obviously going to be the case each time it's a subchain. So that is methyl. Now I'm sure you've noted that actually we always need to put the position of the subchain. So from which direction are we going to get the lowest number? So from this direction we have 1, 2, 3, it's on carbon 4. If we were to start from the other side, 1, 2, 3, it will be on position 5. So I'll go for the lower one. So I've already introduced you to, I don't know, 2 rules already. One is that you need to give the subchain the lowest possible positioning, and then the other one is the parent part there is supposed to be the longest chain of carbons. Okay, we can now move. So now let's try to modify this same structure a bit. On carbon 4 again, let's say we introduced CH2, again, and then CH3. How would we name this compound? How would we name it? And then let's say we modify the top part a bit as well. Where? The joining is supposed to be here. So CH2, CH2, CH3. How would you name this compound? How would you name it? So the first thing is to identify the longest chain. Okay, so we've already counted that the horizontal chain is 8 straight. It's 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. What if we decided to 10? So 1, 2, 3, 4, 5, 6, 7, 8. It's also giving us 8. Okay. And then, okay, so we can do this. We can cut on that so that it becomes 3 there. So in such a case, the horizontal one would become 8 carbons, would become now 7, and then the branching one would become 8 carbons, which would now become the longest. What I'm just trying to tell you is it's not always going to be the case that the horizontal one is going to be the longest. No, not at all. Not always. So go always for the longest chain. Don't just go for the horizontal one because you deceive yourself. So if we count again, you'd see that for the horizontal we have 7. 1, 2, 3, 4, 5, 6, and 7. But if you branch off, 1, 2, 3, 4, 5, 6, 7, 8. So we'll go for the branching one because it is longer. Okay? Because it is longer. So some of you may already be asking, what happens in a case where they are of equal length? So I'll tackle that later on, where both the horizontal and the branching one are of the equal number of carbons. Okay. So in this case, if we branch off from there, it tells us that the other part, the other remaining part, is the substituent, okay, or the subchain. So how many carbons does it have? It has got 2. So as an alkyl, for the 2 carbons, it's ethyl. So it becomes an ethyl. Okay. Now, on what position is it? So of course, ethyl octane. Octane is coming from the 8th longest chain of the carbon. So obviously, it is going to be shorter if we start from this side. So 1, 2, 3, and 4. So it is joining on carbon 4. So 4 ethyl octane. If we start from the other side, it will be position 5. So we'll go for the lower one. So with whatever we've talked about, be you're at liberty of trying out this very one that is here. So how fast can you easily name this one? Okay, so the first rule you already know is to just basically get to identify the longest chain. Which one is the longest chain in this case? So 1, 2, 3, 4, 5. So if I proceed, we'll just end up with 6 for the horizontal. If I go down, 5, 6, 7. So 7. So 7 is the longest part. Of course, you can even also count this way if you want, but it always looks short. So 7. So 7 is what? Is it heptane or hexane? Is it hexane or heptane for 7? Okay. So in this case, 1, 2, 3, 4, 5, 6, 7. So 7 is heptane. Okay. So we've identified the longest chain to be this part. So whatever is not connected to that remains now the prefix or the subchain. So in that case, it is ethyl, which is on position number what? So count from the shorter side. So 1, 2, 3. It is connected on carbon 3. So I don't want you to make a mistake of counting from the shorter side and then you reach where the carbon itself is. No, you count the carbon which is part of the longest chain where the substituent is connected, not the position of the carbon itself. What I mean by that is some of you may count 1, 2, 3, you even count the carbon itself 4. No, that is wrong. Look at the longest chain, the root of the parent chain, and then at the position where the external subchain is connecting, that is what now we are calling the. So this is not actually ethyl, this is actually methyl because it is only a single carbon, so it's 3 methyl instead. Okay, so don't forget the prefixes. We've got methyl, ethyl, propane, of course propyl for in terms of alkenes, and then butyl, pentyl, hexyl, heptyl, octyl, nonyl, and dicyl. Okay. So from the previous one, what basic rule did you get here? So we actually just repeated the very first one, where we said, of course, you get the lower positioning, right? You get the lower positioning because from the other direction, of course, you'd see that it would be longer. It will be on 1, 2, 3, 4. It will be position 5. So you go for the shorter one. Give the substituent or the prefix a shorter positioning on the structure. Okay, look at this one now. Very interesting. So the first rule in naming every compound is to identify the longest chain. Let's try to do that in this case. So it's very obvious the horizontal one is longer. Unless otherwise, let's try it. 1, 2, 3, 4, 5, 6. Okay, interesting. Well, but if we started from the top again, it would be 6. 1, 2, 3, 4, 5, 6. Now this is the case what I was talking about, where if you start from, if you try two chains and then they are all giving you the longest one, so what do you follow? What rule must you apply in such a case? So the rule you must apply basically is to get to try to name both, and then you make a decision thereafter. So let's try. So we'll try to consider first of all the horizontal one. We'll try to consider the horizontal one, where we have 1, 2, 3, 4, 5, and 6, right? For the horizontal one. So in such a case, the six carbons we're talking about are representing now hexane, right? And then the subchains that we have this one and the other one. So the one with a single carbon is called methyl, right? So this is methyl. So on position what? On position 2. So we have 2 methyl. And then the one on top has got 2 carbons, which is makes it to be, of course, it is on position number 3, which is ethyl. So this is the first example we're having where we've got more than one subchain or more than one substrate. So how would you name this one? So this is the case where I'll now introduce you into the aspect of you should be able to alphabetize the substance. Don't look at the positioning, but instead alphabetize them. So if you look at M and E, which one comes first? So it's E, right? So it will be 3-ethyl, and then an ethane for 2-methyl again. So the positioning, I started from this direction because it looks closer to the subchains, unlike the other side. Okay, so that is the possible naming for the first one. Now what happens in a case where you consider this other one? Okay, so if you consider the other one, the family name is still going to be hexane because of the 6 carbons, but that would mean that this whole entire part becomes a what? Becomes a subchain as one, because it is connected as one using the middle carbon. Okay, so in a case where we've got 3 carbons and then the subchain is connecting using the middle one, we call that isopropyl. So it is an isopropyl on position what? So 1, 2, 3. On position 3, I've taken that because it is shorter, so 3-isopropyl. That would be the name of the other one. So which one are we going to go for? Which one are we going to go for? So the rule is go for the name that has got more substituents. If you've got chains of equal length, the naming should go with the one with the most substituents, or the one with a greater number of subchains. So in this case, the one which with more substituents or more subchains is which one? Is the first one, which has got 2. So that would be the correct name for that. Okay, so previously we've already talked about the issue of alphabetizing, the, the alkyls or the prefixes that you have, and then we also talked about the aspect of going for the chain with more substrates. Okay, so that being the case, if you look at what we have, which one are we going to go for in terms of naming? So feel free to pause the video and apply whatever we've learned so far and see the one that you're going to go for. And then I'll insert one more there. H2. Okay, so after introducing the middle one there's a reason why I was trying to insert that, because I want it to come out in a certain way. So we'd get up having a total of 10 if you count again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So telling us that the family or the root is decane. That's the longest chain, decane. Of course, some of you would still argue if you tried counting from the bottom as well. 1, 2, 3, 4. You would end up with a 10 as well. Even if you started from the top, you would end up with a 10 as well. But even if you do, one thing is still clear. Even if I'll start from this one, in such a case, the subchains would be 1, 2, 3, and 4. Essentially, which is like the same. Okay? Essentially, it is the same. So it doesn't matter which one you consider. So I'll consider the horizontal one for simplicity's sake. So if you consider the horizontal one, this is ethyl because it is adding 2 carbons. So is this one ethyl, and then the one with a single one is methyl, and then so we still have another ethyl again. Okay, so this basically is a case where now you have a single substrate or subchain coming more than once, which is the ethyl. So in such a case, you need to count them. So if there are 2, you have to prefix them with di. You would say diethyl. In this case, there are 3, so you instead say tri. Okay, so say tri because they are 3. So tri and then ethyl. So triethyl. Okay, so now one thing that I want you to know is, in terms of alphabetizing, if you look at triethyl, and then the other substance that we have is methyl, which one is going to come first in terms of alphabetical order? So if you compare M and T, you will notice that M will come before. But in terms of the rules that we have of naming these, we don't basically work that way. We look at the actual name of the substrate. We ignore these prefixes declaring or determining the number of the substance that we have. So the di, the tri, the tetra, the sake of the tertiary of things are ignored. So we do not alphabetize the di, the tri, and then also the tertiary carbon, the secondary carbon, and also the tetra, which would represent 4 substrates. We don't alphabetize these. Okay, very important. But of course, take note that we do alphabetize the special prefixes iso, which represents those 3 carbons where it's connected using the middle carbon, and then also cyclo, which we're later going to take on, which represents compounds that are cyclic. In other terms, they are joined in this form, such also alphabetized. Okay. So with that in mind, the other thing that is very important is we basically get to, since we've got 3 of ethyl groups, we need to also indicate their positionings by looking at what we have. So which side, if you look at this horizontal chain, is going to give us the lowest number or lowest possible combinations of the subchains. So obviously if we start from the left side, we'd get position 3 earlier. If we start from the other side, the first subchain is going to be on position 4. So we'll start from the side which is giving us a lower combination. So we've got 2 ethyl groups on carbon 3. So I'll say 3, 3, and then comma, the other one it becomes on, so 4, 5, 6. So it comes on position 6. And then methyl comes on position 7. So the naming would be 3, 3, 6, hyphen, triethyl, and then 7, methyl. The longest chain is decane. So there you have it. So the key rules here is use commas to separate the prefixes positioning in cases where you've got more than a single prefix. And then of course the prefix that is used to denote the number of such subchains you have is not alphabetized. Okay, of course including the secondary and the tertiary TRT are also not alphabetized. The only ones you alphabetize are iso and cycro. Okay, pretty much. So we are on another one. So we are at liberty of pausing the video and just trying it out. Are you enjoying this video lesson? So you can actually access the entire topic you are watching or the entire practice questions of a video that you may be watching right now. So if you go to our website is transcendedinstitute.net. Okay, so there are 3 ways that you can access our videos. So you can use Patreon, you can use channel memberships. If you're in a country where it's allowed, you'll be able to access our full topic videos and full practice questions. So alternatively, you can access the videos using our learning portal. The link is learn.transcendedinstitute.net. So I'll show you a few videos that you can have access to after registering. So for example, if you had to open mathematics as at now, these topics are the ones that are available, which you can learn from scratch. I can just give you an idea of, so you like learn everything from scratch, meaning that even if you're learning something for the first time, these videos are there to help you with concepts as well as practice questions. So for example, these are tutorial sheet solutions from different tutorial sheets, which can help you as well get to learn faster and remember. So binomial as well, there it is. And of course this applies to all these other topics that are available, trigonometry as well, calculus, depending on the topic that you're interested in mathematics. So you can just head over to the site at now to check what is currently available. Even without registering, you should be able to see the content in each topic. So let's assume you're interested in physics. These are the topics available as at now. So if you open chemistry, these are the topics available as at now: electrochemistry, stoichiometry, thermochemistry, kinetics, equilibrium, solubility, equilibrium, atomic structure. So trust me, if you open these videos, you might have learned the topic in full. Let me show you stoichiometry. So stoichiometry, we have all the way up to 21 videos, including the tutorial sheet solutions, which will help you to practice both the concepts and also prepare for questions. Okay, so feel free to head over to the site and check out these videos on your own. So equally biology videos are also available, which you can also basically get to access. So these are the topics available so far. Yeah, so pretty much these are the ways you can easily access our full membership videos that you don't have access to on the channel. Okay, so here the longest one is which one? 1, 2, 3. 1, 2, 3. Okay, so that's not actually the way you count. So if you're counting from the bottom one, you would count this way instead. So 1, 2, it is connected using the middle carbon. So you count 1, 2, and then 3, 4, 5, 6, 7. So what is 7 for the one coming from the bottom? And then from this side, 1, 2, 3, 4, 5, 6, 7, 8. So the horizontal one is the longest in this case, clearly. Okay, so don't count all these and then start counting that one. No, the chain, it needs to be clear on how they are connected. So it's 1, 2, 3. Unless if it was connected using the carbon at the end, that's when it would count. Okay, what I mean by that, where this one is not here and then it's at the end, you would count all the 3. Okay, let's be clear on that. So in this case, the longest chain is the horizontal one, which is giving us 8. So that is octane as the root of the parent name. And then the subchains, we have this one and also the other one. So the one on top is clearly methyl because it is having a single carbon. The one on the bottom is propyl because it is having 3. Now it is a special one because it is connected using the middle one, so it becomes iso. Now we need to give positionings. Which positioning is going to be easy, or going to give us lowest possible combination? So if you start from the side closer to the end, so we'll start obviously from this side because that one is on 2. So 1, 2, 3, 4, and 5. So this is on position 5, that is on position 2. So how do we name them? Which one is going to come first? Is this isopropyl or methyl from the rules that we've talked about? So pause the video and give it a name. So the expected name is going to be 5 isopropyl and then 2 methyl octane. The reason is simple. So we said you can alphabetize iso and cycro. So if you look at I and M, I comes earlier in the alphabetical order, so that's how you name it. Don't ignore iso and cycro. Only ignore the di, the tri, the tetra, the tertiary, and the secondary. Okay, very important. Okay, so we have another one there. So at liberty of pausing the video and just trying it out, applying all the rules we've talked about so far. So let's try to count. So the horizontal one is obviously 1, 2, 3, 4, 5, 6, 7, 8, and 9.